In this video, we are going to discuss the oxidation state of group 16 elements. The valence electronic configuration of group 16 elements is Ns2np4, and they require 2 electrons to complete octet, and therefore common oxidation state of group 16 elements is -2. Additionally, sometimes they show +2 oxidation state also, and -2 oxidation state will be there when they gain 2 electrons, and there will be +2 oxidation state when these elements lose 2 electrons out of 6. Now oxygen shows -2 oxidation state as a stable oxidation state. Exceptionally, in oxygen difluoride it shows +2 oxidation state. In hydrogen peroxide it shows -1 oxidation state. Other elements in addition to +2, that is sulfur, selenium, tellurium, polonium, these elements shows +4 and +6 oxidation state also. But the stability of +6 oxidation state decreases down the group, that is from sulfur to polonium, and stability of +4 oxidation state increases down the group, and this is due to inert pair effect. Why stability of +4 oxidation state increases from sulfur to polonium or from selenium to polonium? Reason is inert pair effect. It means tendency to lose electron for this Ns electron, it is decreases from sulfur to polonium, and therefore this is called as inert pair effect. And because of inert pair effect, that is reluctance of Ns electrons to lose, because of this stability of +4 oxidation state increases down the group. Now next point is anomalous behavior of oxygen. In group 16, the elements are oxygen, sulfur, selenium, tellurium, polonium and livermorium. Oxygen shows different properties. Some of the properties of oxygen are different than the rest of the elements. This is called as anomalous behavior of oxygen, and reason for this anomalous behavior is oxygen is having too small size as compared to other elements. Oxygen is having high ionization enthalpy. Its electronegativity is also higher than the rest of the elements, and most important thing is in oxygen d orbitals are absent. These are the reason for anomalous behavior of oxygen. Now first important difference of oxygen than rest of the elements is oxygen molecule is diatomic, whereas other molecules are polyatomic like S8, Se8, okay, T8, like that. So these are the octatomic. This is the first difference. Oxygen is a gas, other elements are solids. So physical state of oxygen is different than the other elements. Most important thing is oxygen is paramagnetic, whereas rest of the elements, these are the diamagnetic. Oxygen shows oxidation state, stable oxidation state equal to -2. Sometimes it shows -1 also, that is in hydrogen peroxide. Whereas other elements, sulfur, selenium, tellurium, polonium, they shows -2, +2, +4, +6. Oxygen forms hydrogen bonding. It forms hydrogen bond. Because of high electronegativity, it forms hydrogen bond. But tendency to form hydrogen bond, it is less or almost negligible for rest of the elements. Oxygen form ionic compounds. So oxides, metal oxides, these are the ionic. Whereas rest elements, preferably they form the covalent compounds. One of the important hydride of oxygen, that is water, H2O. So hydride of water exists in liquid state, whereas hydrides of other elements like hydrogen sulfide, hydrogen selenide, hydrogen telluride, these are gases. Now covalency of oxygen is 2, but other elements can have a covalency equal to 4. So covalency of other elements can be exceed to 4, but covalency of oxygen, it is not exceed to 4, it is 2 only. Oxygen is able to form p-pi multiple bond, whereas other elements, they are unable to form p-pi multiple bond. So this is about the anomalous behavior of oxygen. Now next important point is allotropy of various elements of group 16. So allotropy means it is a phenomena of elements to have a different physical forms. Okay, some elements exist in different physical forms. These are called as allotropes. Okay, and oxygen exists in 2 allotropic forms, O2 and O3, that is dioxygen and ozone. Dioxygen is paramagnetic, ozone is a diamagnetic. Sulfur exists in several allotropic forms, that is alpha sulfur, also called as rhombic sulfur. It is stable below 368 Kelvin. It has a puckered ring structure like this, puckered ring structure, and it's a cyclic molecule. In one molecule there are 8 atoms, and therefore its molecular formula is S8. Beta sulfur or monoclinic sulfur exists above 368 Kelvin. It also having puckered ring structure. It is cyclic, exists as a S8 molecule. Gamma sulfur also, it is a pale yellow sulfur. It is also cyclic, it having cyclic ring structure. Then plastic sulfur exists above 625 Kelvin. So when sulfur is heated up to 625 Kelvin, undergoes polymerization and it becomes plastic sulfur. It is soft, rubber-like and metastable, and this is the formula, or this is representation of plastic sulfur. So you can see it has a catenation tendency, and therefore it shows polymeric structure. It is a plastic sulfur. It is metastable or less stable. Then colloidal sulfur. Now when hydrogen sulfide is passed through nitric acid, there is a formation of sulfur which is suspended in the water. This nitrogen dioxide gas goes off, and this sulfur, it is suspended in water, and it becomes a colloidal sulfur. Similarly, when hydrogen sulfide is mixed with sulfur dioxide, then there is a formation of sulfur which is suspended in water, and it becomes a colloidal sulfur. Then angel sulfur, it is having 5 rings arranged in chair conformation. Then polysulfur molecules. So sulfur exists in polysulfur state like S7, S9, S10, S11, S12, S18, S20. Especially hydrogen polysulfide like H2S8, when treated with polysulfur dichloride like S2Cl2, S4Cl2, then we get polysulfur molecules like S10 and S12, etc. So by changing composition of hydrogen polysulfide and polysulfur dichloride, we get different polysulfur molecules. Then selenium exists in 2 important allotropic forms. Its molecular formula is Se8. Crystalline and amorphous selenium is there. So crystalline selenium may be red or grey, and amorphous selenium, it can be brown, red or vitreous. Then tellurium, it may be a crystalline or amorphous. Crystalline form, it is also called as metallic tellurium, and amorphous form, it is non-metallic tellurium. Polonium exists in 2 important allotropic forms, alpha polonium and beta polonium. Now next important point, that is the chemical properties of group 16 elements. Action of air. Actually, on heating with air, sulfur, selenium, tellurium, they form the dioxides. Sulfur reacts with air, that is oxygen, and forms sulfur dioxide. Selenium gets converted to selenium dioxide. Tellurium forms tellurium dioxide. Then action of acids. So when these elements treated with concentrated nitric acid, then there is a formation of, or there is oxidation of this sulfur, selenium into acid, corresponding acid. So sulfur gets converted into or oxidized into sulfuric acid. Selenium also reacts with nitric acid, and there is oxidation of selenium into hydrogen selenite. There is a oxidation of selenium. Similarly, group 16 elements reacts with metals. For example, sulfur reacts with copper, and there is a formation of copper sulfide. Selenium reacts with cadmium, and there is a formation of cadmium selenide. They reacts with non-metals also, other non-metals. So sulfur reacts with carbon, there is a formation of carbon disulfide. Selenium reacts with chlorine, 2 moles of chlorine, and there is a formation of selenium tetrachloride. Tellurium also reacts with iodide or iodine, and there is a formation of tellurium tetraiodide. Sulfur reacts with fluorine, 3 moles of fluorine, and we get most common compound, that is sulfur hexafluoride. So these elements, that is sulfur, selenium and tellurium, when added in alkali, they gets dissolved. For example, sulfur when added in alkali like sodium hydroxide, there is a formation of sulfide and sulfite, and therefore sulfur gets dissolved in alkali. As an example, when sulfur is added in sodium hydroxide, NaOH, then there is a formation of sodium sulfite, that is Na2SO3, and there is a formation of Na2S, that is sodium sulfide, and this is the sodium sulfite. This is sodium sulfide and water. So as soon as sulfur is added in alkali, suitable alkali, we get sodium sulfite and sodium sulfide, and sulfur gets dissolved in sodium hydroxide. So these are the some chemical properties of group 16 elements. So in this video we discussed about the oxidation state. First of all, we discussed about the oxidation states of group 16 elements, and as I told you, oxygen shows -2 oxidation state as a common oxidation state. Other elements, in addition to -2 or +2 oxidation state, they show +4 and +6 oxidation state. Stability of +6 oxidation state decreases down the group, and stability of +4 oxidation state increases down the group. This is because of inert pair effect. Then we discussed about the anomalous behavior of oxygen. Oxygen shows anomalous behavior, or it shows some different properties than rest of the elements. This is called as anomalous behavior. And then we discussed about the chemical properties of group 16 elements.